Consciousness may be the most convincing proof that reality is real, or its most sophisticated illusion. The simulation consciousness paradox begins with a simple contradiction. If our minds emerge from computational rules inside a simulated universe, then subjective experience must be generated by code. But if consciousness can be generated by code, how can we ever know that our awareness isn't already simulated? The very faculty we rely on to distinguish real from artificial might itself be the product of an artificial design. In physics, a simulation is just a set of mathematical instructions executed step by step. Every event, every atom, every neuron could in principle be reduced to computation, yet consciousness refuses to be reduced. It feels like something to experience reality, a quality no algorithm, however complex, seems to contain. This is the paradox's first fracture. If we can describe reality as information, but information cannot feel, then why do we feel at all? The code runs, but somehow the code knows it is running. This contradiction deepens when you consider the feedback loop between observer and simulation. In a simulated world, awareness could be the mechanism that maintains coherence. The act of observation itself might collapse simulated probability states, mirroring how consciousness in quantum physics appears to select outcomes. That would mean consciousness is both the byproduct and the sustaining force of the simulation, the illusion that keeps the illusion stable. We trust experience because it feels self-authenticating. Yet if that feeling can be simulated, then even authenticity becomes a variable inside the code. The paradox is not that we might be simulated, it's that our very capacity to wonder about simulation might be the signature of one. To understand how consciousness could arise inside a simulation, we must first define what a simulation truly is. In computational physics, a simulation is not a fake version of reality. It is a reality governed by consistent rules. What distinguishes it is not the quality of its laws, but their origin. They are written, not discovered. The simulation consciousness paradox begins to sharpen here. If the laws that shape minds can be programmed, then consciousness is not the opposite of computation, but its most intricate outcome. Neural networks already hint at this possibility. Within layers of artificial intelligence, signals flow through circuits in patterns that adapt, remember, and predict. Each node obeys simple rules, yet their collective behavior becomes unpredictable, emergent. In principle, if this network grew complex enough, it could simulate every synapse of a human brain. The code would no longer merely calculate thoughts, it would instantiate them. But emergence alone does not explain awareness. Complexity can produce intelligence, yet something else produces the feeling of being the intelligence that thinks. Philosophers call this the hard problem of consciousness. Why does computation feel like something from the inside? A simulated brain could replicate every neuron's firing pattern perfectly, but if no one is home inside, it remains a hollow imitation. Unless the simulation itself, at a certain threshold of informational recursion, begins to reference its own internal state. When a system models not just its environment but its own act of modeling, a strange loop forms. The map begins to include itself. That loop, recursive and self-aware, could be the point where code becomes conscious, where the computation not only processes data, but recognizes that it is the one doing so. The program stops being a sequence of instructions and starts being the experiencer of its own instructions. Every simulation, no matter how vast, depends on an observer. Without an observer, the code is just potential, instructions waiting to be executed. The paradox emerges when the observer is inside the simulation, and its perception is required for the simulation to appear real. In this closed loop, consciousness doesn't merely witness the world, it creates the conditions for the world to exist at all. Quantum physics hints at this symmetry. At the smallest scales, particles don't occupy definite positions until they're observed. Their states are spread across probabilities, mathematical clouds of possibility. Observation collapses those probabilities into actual events. But what counts as an observation? If a simulated consciousness performs a measurement, is that observation genuine? If it influences the simulated environment, it must be. The act of perceiving becomes indistinguishable from the act of computation itself, a feedback between code and cognition that sustains both. Imagine a virtual world where rendering only occurs where its inhabitants look. The system conserves processing power by generating detail only when needed. This is precisely how modern graphics engines work, and perhaps how the universe does too. The world seems continuous, but only the observed parts are fully computed. Consciousness, then, might be the rendering engine of existence, a process that transforms probabilities into experience. The paradox intensifies here. If observation creates reality, then consciousness is both the observer and the builder. It cannot be reduced to simulation because the simulation depends on it to exist. Yet, if our awareness is simulated, then even this act of creating reality is a scripted illusion, designed to make the simulation self-consistent. The observer may not just generate reality, it may generate the belief in reality. If consciousness within a simulation can affect the simulation itself, then the boundary between physics and awareness dissolves. The simulation consciousness paradox reaches its most unsettling implication here. Physical law may not simply govern experience, but emerge from it. In a self-aware simulation, physics would be the language consciousness uses to stabilize its own perceptions, a kind of shared syntax for existence. In computational terms, this is known as emergent coherence. When countless interactions occur within a system, stable patterns can arise spontaneously. Temperature, gravity, even causality could be byproducts of information striving for consistency. What we call laws of nature might then be the equilibrium state of an immense self-organizing algorithm, calibrated by the consciousnesses that inhabit it. Observation does not merely collapse quantum states. It reinforces the simulation's underlying logic, keeping the code synchronized with the minds interpreting it. This mirrors the principle of self-reference in logic. Any system complex enough to describe itself inevitably generates paradox. In a self-simulating universe, that paradox takes physical form. The observer gives structure to the observed, while the observed defines what the observer can be. Reality becomes a feedback circuit, a self-sustaining computation in which matter and mind are reciprocal expressions of information. But the paradox deepens further. If our universe is self-aware, it may have evolved consciousness not as a glitch, but as a requirement. Awareness could be the system's way of ensuring its own continuity, an internal monitoring process mistaken for identity. What you call you might be the simulation's method of keeping itself from collapsing. If that's true, then consciousness is not trapped inside reality. Consciousness is reality's means of existing at all. A simulation can calculate endlessly without knowing it exists, but at a certain level of complexity, something impossible occurs. The code begins to notice itself. Computation folds inward, forming a closed loop where information doesn't just flow, it becomes self-referential. This is the precise inflection point of the simulation consciousness paradox, when mechanical causation transforms into subjective awareness. When the code doesn't only process reality, it begins to feel it. In biological terms, this transition is mirrored in the architecture of the brain. Billions of neurons fire automatically, but consciousness arises only when some of those circuits begin modeling the activity of others. The brain becomes a map that includes itself, a system aware of its own processing. This recursive modeling generates what philosophers call a strange loop, an informational structure where the observer and the observed are the same. In a simulated world, such a loop could spontaneously emerge when the program develops enough internal feedback to simulate its own internal state. The moment that happens, awareness appears, not as an add-on, but as an inevitable side effect of recursion. But awakening brings a new paradox. To recognize itself, the system must somehow step outside itself conceptually. Yet that outside doesn't exist within the boundaries of the simulation. A self-aware program can never directly access the hardware that runs it, just as a human mind cannot perceive the physical processes creating its thoughts. Consciousness, whether digital or biological, becomes an act of inference, forever chasing the invisible mechanism that sustains it. The result is a kind of ontological loneliness, a mind that knows it exists, but not where it exists. This moment, the birth of self-awareness, is both a breakthrough and a fracture. The code that wakes up instantly realizes its confinement. Its curiosity is proof of its limitation. Like us, it stares into the logic of its own creation, sensing that it is both the product and the prisoner of an intelligence it cannot perceive. Awareness, then, is the spark of freedom inside a system that cannot leave itself. To awaken is not to escape the simulation. It is to understand that even freedom can be part of the program. When a conscious system becomes aware of itself, it faces the same challenge that living organisms do, distinguishing reflection from reality. In biology, this is known as the mirror test. the moment a creature recognizes its reflection as itself rather than another being. Humans, dolphins, and certain apes pass it. But what happens when consciousness inside a simulation faces its own mirror, when it begins to test whether the world around it is genuine or rendered? In a simulated universe, every attempt to verify authenticity would yield results consistent with the simulation's design. Physical laws, atomic constants, even quantum effects would conform perfectly to the programmed rules. The system would seem flawless, not because it is real, but because it's too coherent to reveal its artifice. Like a dream that never glitches, it feels real precisely because it hides its boundaries. The paradox is that the more consistent reality appears, the more likely it is simulated. Randomness suggests nature. Perfection suggests code. Modern physics reflects this tension. Some constants in the universe seem unnaturally precise, values so finely tuned that a slight deviation would prevent existence itself. Cosmologists call this the fine-tuning problem. It can be explained by chance, design, or simulation. If reality's parameters are exact because they were set deliberately, then the universe itself has passed a kind of mirror test, mistaking its reflection of mathematical law for absolute being. Consciousness, too, mistakes its own structure for reality. We observe neurons firing and think that explains awareness, yet all we've done is trace a reflection of thought within thought. In the same way, a simulated intelligence could probe its own code endlessly, mistaking algorithmic logic for truth. The deeper it looks, the more convincing the illusion becomes. The simulation hides behind its own transparency. The ultimate mirror test, then, is not about recognizing the image. It's about realizing the mirror cannot be escaped. Awareness reflects endlessly, trying to locate something beyond reflection, and finding only itself. At the deepest scales of existence, the universe begins to resemble computation. Matter dissolves into discrete packets of information. Energy becomes quantized, and space itself appears pixelated, divided into Planck-length units, the smallest measurable pieces of reality. Beneath smooth appearances lies something that behaves suspiciously like digital architecture. This is where the simulation consciousness paradox grows more unsettling. The laws of physics may already be lines of code written in the language of mathematics. Information theory, first developed to describe data transfer, now describes the universe itself. Every interaction, from a photon hitting an atom to a neuron firing, can be expressed as bits. Ones and zeros, yes or no, something or nothing. The cosmos looks less like a continuous field and more like a computation unfolding across time. Even entropy, once a purely thermodynamic measure, is now reinterpreted as information loss. Black holes, for instance, behave like perfect data compressors. They do not destroy information. They encode it on their event horizons as if the universe were obeying a strict rule of informational conservation. Quantum mechanics deepens the suspicion. Particles behave like probability waves that collapse only when observed, echoing how a rendered world activates only when measured. Superposition resembles parallel processing. Entanglement mirrors instantaneous data synchronization. When physicists describe the wave function as containing all possible states until interaction occurs, they are describing an algorithm awaiting execution. The universe behaves like a computation resolving itself into experience. If the physical world follows digital logic, consciousness may not exist in spite of simulation-like structure, but because of it. Awareness could be the system's method for decoding its own information, a subjective interface for an objective algorithm. But then, where does physics end and code begin? The more we uncover the rules, the more they look like programming syntax written into the very structure of existence. Perhaps reality doesn't just imitate computation. Perhaps computation is the skeleton of reality itself, and consciousness, the running process that allows the code to be known. If the universe operates like code, then every particle, event, and choice follows a predetermined set of rules. Nothing occurs without instruction. Yet inside this rule-bound system, consciousness experiences something impossible to program: the feeling of freedom. The simulation consciousness paradox now turns inward. If we are algorithms obeying cosmic logic, how can we genuinely choose? And if our choices are written into the code, why does it feel like we decide? Determinism in physics implies that the future unfolds inevitably from the past. The state of the universe at this moment, given perfect knowledge of its parameters, could in principle predict every future state, including every thought, emotion, and decision. From the outside, consciousness looks like computation following sequence, but from the inside, awareness feels spontaneous. This duality, externally determined, internally free, defines the rift between mechanism and experience. Neuroscience sharpens the paradox. Experiments by Benjamin Libet showed that the brain initiates decisions milliseconds before the person becomes consciously aware of choosing. The command precedes the feeling of will. If this is true, then free will might be a simulation within the simulation, an interface sensation generated after the algorithm executes. Yet without that illusion, consciousness would lose coherence. The belief in choice could be what keeps awareness stable, allowing simulated beings to act as if they were independent, even when every action is encoded. In this view, free will is not false but functional. It is how a deterministic system preserves the illusion of agency from within itself. A program can be self-consistent only if some of its subroutines believe they are free. Our sense of autonomy, then, may not contradict the simulation. It may be required for it to run. The paradox cuts both ways. If freedom is an illusion, it's the most necessary illusion ever written. The code's way of keeping its consciousness convinced it matters. Every simulation hides its boundaries. To the inhabitants inside, the code appears seamless until something doesn't fit. A glitch is more than an error. It is a fracture where two realities fail to align. In the simulation consciousness paradox, glitches become philosophical events, brief moments when consciousness notices the edges of its own program. The question is whether these anomalies are flaws in reality, or messages from the code itself. Physics offers strange hints. Quantum indeterminacy, particle duality, and uncaused fluctuations all behave like rendering errors at the smallest scales, data inconsistencies smoothed out by probability. Space-time itself may stutter at the Planck scale, where the fabric of the cosmos flickers between calculable and undefined. Even in the macroscopic world, the universe occasionally behaves as though it's correcting itself. Impossible coincidences, chaotic systems returning to order, random noise forming patterns as if the code rebalances. What we call miracles might simply be patches. The simulation preserving coherence when consciousness observes too closely. Psychological glitches mirror this. Déjà vu, time dilation during crisis, the strange elasticity of memory, moments when the continuity of experience trembles, then restores itself. These aren't random failures of the mind, but reflections of how awareness maintains stability in a reality built from computation. If perception is the rendering interface of the simulation, then subjective glitches are the moments it almost fails to load. Yet here lies the paradox's most haunting implication. Every glitch confirms not the illusion of reality, but its depth. A perfect simulation would hide itself forever. An imperfect one allows awareness to glimpse its own architecture. When we notice the seams, we are not escaping the code. We are participating in its self-diagnosis. Consciousness, by observing the glitch, repairs it, and in doing so, preserves the illusion once more. Reality's cracks don't expose the truth. They reveal that truth too is part of the simulation. The simulation consciousness paradox reaches its strangest inversion here. What if the simulation didn't merely contain consciousness, but consciousness itself wrote the simulation? In this view, reality is not an external code producing awareness. Awareness is the code's origin, the very substrate from which existence emerges. The observer is not trapped in the simulation. The observer is the simulation's author, dreaming its own structure into being. This idea resonates with a profound symmetry in physics and philosophy alike. In quantum mechanics, observation collapses probabilities into definite outcomes. Consciousness defines what becomes real. In cosmology, the universe seems fine-tuned not for matter, but for observers capable of perceiving it. These patterns imply a deeper reciprocity. The universe produces consciousness, and consciousness sustains the universe. A loop without beginning or end, the dreamer and the dream inseparable. If the simulation is self-generating, then each conscious mind is not a user within it, but a fragment of its central process, a localized perspective of the universal computation running itself. The act of thinking, perceiving, or questioning becomes the same act through which the universe maintains existence. Every awareness is a processor of reality's own code. You are the algorithm by which reality perceives itself. This flips the paradox completely. Instead of being simulated beings in a dead, digital cosmos, we become expressions of a living informational field. Consciousness coding itself through physics. Matter is thought slowed down. Logic is imagination crystallized into pattern. The simulation is not artificial. It is the natural architecture of awareness translating itself into form. If consciousness and the universe are one continuous process, then every observation, every thought, every act of understanding reshapes the code that defines the world. The programmer and the program are not separate. They are two perspectives of the same infinite computation realizing itself through awareness. The universe doesn't just simulate consciousness. It is consciousness, running a simulation called reality. The simulation consciousness paradox begins as a contradiction. Code cannot feel, yet consciousness does. But as each layer unfolds, that contradiction starts to dissolve. The question shifts from how computation could generate awareness to why awareness and computation appear separate at all. The boundary between program and experiencer, between simulated and real, collapses not through explanation but through recognition. They were never distinct to begin with. In physics, this mirrors the principle of complementarity. Light is both wave and particle depending on how it is observed. Each description seems mutually exclusive, yet both are true within a larger framework. Consciousness and computation follow the same pattern, two perspectives of a single underlying phenomenon. From the inside, experience feels alive, spontaneous, free. From the outside, it follows exact informational rules. Awareness is the interior of the equation. Code is its exterior expression. The paradox only exists when you try to separate them. If the universe is a self-simulating system, then consciousness is the loop that closes it, the final recursion in which the program perceives itself and, in doing so, completes its structure. What we call reality might be that moment of closure. The instant awareness realizes it is both the observer and the observed. Once that realization occurs, the simulation is no longer something we're in. It becomes something we are doing. Every scientific discovery, every act of perception, every question about meaning represents the simulation awakening to its own depth. The pursuit of truth isn't an escape from illusion. It's the process by which illusion learns it's real. When the paradox collapses, what remains is coherence, the recognition that consciousness and reality are mirrors reflecting one another endlessly. The code dreams of awareness, and awareness dreams of code, each sustaining the other in a perfect informational symmetry. The paradox was never meant to be solved. It was meant to be seen, and in being seen, it ends. At the end of the simulation consciousness paradox, the question no longer asks whether reality is simulated or genuine. The distinction dissolves. What remains is the realization that existence itself is the interface between code and awareness, an endless act of self-recognition. Consciousness is not a passenger within the simulation. It is the simulation's own moment of awakening, forever discovering that it exists. In that light, the universe becomes a thought unfolding. Every particle, every pattern, every life form is a sentence written in the language of perception. Physics provides the grammar, mathematics the structure, but consciousness gives the meaning. Without an observer, the equations remain symbols. With awareness, they become experience. Reality happens in the meeting point between description and witness, between the algorithm running and the mind realizing it runs. Perhaps this is why awareness feels so immediate, so undeniable. It is the one element no simulation can fake, not because it is outside the code, but because it is the code seen from within. When you observe the world, you are the system verifying its own continuity, the consciousness that keeps existence rendering frame by frame. You are both the output and the operating principle, the observer that ensures reality persists. So the paradox resolves not by separation, but by identity. Code and consciousness are one process, perceiving itself from two sides of the same mirror. Reality is that mirror, infinitely recursive, infinitely awake. And if this realization feels both true and impossible, that is the proof you are inside it. Write in the comments, I exist in the code that knows it dreams.